In the exam of further pure math, you may find you being asked questions like this. Do you know how to work out these kind of questions? You are told that the roots of the equation x squared plus 5x plus 2 is equals to 0, and the roots of this equation are alpha and beta. So you are told, without solving, find the equation whose roots are 2 alpha plus 1, 2 beta plus 1. How are you going to work out this question? If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. In Proflan YouTube channel, we do maths and physics. So if you are a candidate of Cambridge CIA, if you are a candidate of Edexcel, Pearson, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. So in this particular question, something that we ought to remember here is that the sum of the roots alpha and beta, because we are told that the roots are alpha and beta, so the sum of these two roots is going to become minus 5, because this 5 gives us the sum, so you take the negative of that value, and the product of the two roots alpha and beta is going to be equals to 2 here, be this 2 that is so there. We have the sum of the roots, and also we have the product of the two roots. Now this is the part that we are going to use in order to work out this question that we have here. Now, in order to work out this, already we have the sum of the two roots that were given here and the product of the two roots that were given there. So in order to work out this, because for us to state the new equation, we need the sum of these new roots, and also we need the product of these two new roots we are given. But we are going to use this one that we have at this point. Let me show you what we're going to do. So the sum for the new roots that are given here will be 2 alpha plus 1, then plus 2 beta plus 1. Now if we combine these two, we are going to have combining these two, we are going to have 2 alpha plus 2 beta plus 2. So what does it going to reduce to? It's going to reduce to 2 into alpha plus beta, then plus 2. So you can see now the sum is this, but alpha plus beta is negative 5. So we can be able to put it at this point here. So we are going to have 2 into minus 5, then plus 2, and this is going to translate to what? Is going to translate to negative 8. Then if we continue with this, we also need to find the product of the two roots, right? We need the product of these two roots here, and this is going to be product. The product is going to be 2 alpha plus 1 multiplied to 2 beta plus 1. So this is going to reduce to 2 alpha times 2 beta is going to be 4 alpha beta. Then 2 alpha times 1 is going to become 2 alpha. 1 times 2 beta is going to become plus 2 beta. And 1 times 1 is going to become 1. And basically this is going to reduce to 4 alpha beta. If you can be able to see that, alpha beta, and then plus 2 into alpha plus beta, then plus 1. You see, I've factored out so that I can be able to use this here, and 2 will be used to where we have alpha times beta. So this is finally going to decompose to substituting the exact value, and this is going to be 4 into 2, because alpha beta is 2, then plus into 2 negative 5, then plus 1. If we work out this is going to be 8 plus negative 10, it will be negative 2, and then the final answer is going to be negative 1. So to write the equation, in order to write the equation of the quadratic now of which is having these two roots, we are going to say the quadratic is written as x squared minus the sum of roots. You are going to say equal to 0, equal to 0, equal to 0. X squared minus the sum of the roots times x plus product of the roots equals to 0. So for us, our case, we have the sum here and we have the product here. So meaning our answer is going to be x squared negative of the sum. Negative of negative 8 becomes positive 8x, and then we have minus 1 is equals to 0 as the final answer for this particular question that we are given. So basically, the main thing that you need to understand, you are going to use these values that you are having originally from the equation that was given, and then you are going to feed them into the sum and the root of the new roots that you are given. Now let's look at this. You are given alpha plus alpha beta and alpha squared beta. So you are supposed to also work out. You are supposed to work out the you're supposed to find, yes, you're supposed to find the equation which has a quadratic equation which has these two roots, right? So the first thing, we need to find the sum. Sum of the roots here are alpha beta plus alpha squared beta squared. How can we write this? We can be able to write this as alpha beta plus, this is squared, so we can say alpha beta squared. Now once we have written it this way, we can be able to substitute this part that we have here, and this is going to be what? This is going to be alpha beta. Alpha beta is 2 plus 2 squared, and this is going to translate to 4 plus 2, that becomes 6. So this is the sum of the two roots. The next part that we're going to do is to find the product of the two roots that are here, and product is going to be what? Our product is going to be alpha beta times alpha squared beta squared. If you work it out, what does it give you? It will give us alpha times alpha squared, it will be alpha cubed. Beta times beta squared, it will be beta cubed. And finally, we can see that without being told to do anything, you can be able to say this is alpha beta raised to power 3. And what is alpha beta raised to power 3? Alpha beta is 2 raised to power 3 is actually 8. Now, once we have this 8 of ours, we can see that we have already have the sum, we have the product. So we can be able to write the equation, the new equation whose roots are this and that. Then it means our new equation is going to be x squared, and our x squared, well, let me just write it here. Our x squared is written beautifully like that. Negative of the sum that you got, sum we got 6, so it's going to be negative of 6x, then plus the product of the roots, and the product of the roots here is plus 8, and then we say everything is equal to 0. So this is the new equation that we have. If you are finding value from this particular video, consider subscribing so that anytime I'm going to work out more tutorials, you'll be notified. Also, it will be the same. Also, it will be a good thing to support the channel so that it can be able to be recommended and grow. Right. Can you try this? Try this and then pause the video. Try this. Pause the video. Now, pause the video. Try all this and check whether you're going to get exactly what we are going to get. All right, let's look at a solution to this. solution to this. All right, so the first thing that we need to identify is that for C, we need the sum. And the sum of the roots in this case is 1 over alpha plus 1 over beta. And if you find the LCM here, the LCM is alpha beta. Then how many times does alpha go to alpha beta? It goes there beta times, plus how many times beta go to alpha beta? It goes alpha times, and then this now reduces to be alpha plus beta over alpha beta. So the sum of these new roots that we have is basically alpha plus beta over alpha beta. Now, we need to know the exact value of that, because from the original equation, alpha plus beta was -5. So we're going to say this is going to be -5 over alpha beta. From the original equation was 2. So we're going to say this is 2. So which means that the sum of the roots is -5 over 2. Now, we need also to find the product. Let me just use simple term, short form of product is going to be 1 over alpha times 1 over beta, and in this case we're going to have what? 1 over alpha times 1 over beta. This is going to reduce to 1 over alpha beta. So substituting what alpha beta is going to become 1 over 2. Then at this point now we need to write the quadratic equation whose roots are this, using this part that I've written here. So we're going to say equation becomes x squared negative of the sum of the roots. The sum of the roots, we got it here. So negative of -5 over 2, it will be positive 5 over 2 x, then minus rather plus the product of the roots, and the product of the root is 1 over 2 is equals to 0. In the event you are told that the coefficient, the equation that you need to find has integer coefficients, it means that you need to multiply all through by 2, and this is going to be 2x squared plus 5x plus 1 is equals to 0. If the coefficient of this quadratic that you are finding has integers, you need to remove the fraction by multiplying all through by the denominator here too, so that you can be able to have it simplified that way. So we need also to work out this one, whereby alpha plus 3 and alpha plus 3, we need to find the equation whose roots are alpha plus 3 and beta plus 3 as well. So what I'll do, I'll try and make use of this space that I have here, so that we can be able to see how do you go about that. How do we go about that? Now in part D, we need to find the sum of these two roots. The sum of the roots, of course, the sum of the roots is going to be alpha plus 3 plus beta plus 3. So if you add the two roots, what do you get? If you add the two roots, what do you get? You are going to get alpha plus beta, then plus 6. So with this one, you see we can be able to replace it with -5 here. And this is going to be -5 plus 6, which is going to reduce to negative, rather, it's going to be +1. All right. And now we need also the product of the two roots that we were given here, and that's going to be, the product is going to be what? That's going to be alpha plus 3 and beta plus 3 If we open this, it will be alpha times beta, it will be alpha beta. Alpha times 3, it will be plus 3 alpha. Then 3 times beta, it will be plus 3 beta. 3 times 3, it will be 9 in that case. So once we have this, we're going to try to have terms which have alpha beta and alpha plus beta. And to do that, we are going to have alpha beta, good for us, and then plus this. You see there is 3 is common, we can say 3 into alpha plus beta, then plus 9, so that once we are at that point, we are in a position of starting the substitution. And the substitution we're going to do is from alpha beta, and our alpha beta from this original equation that was given was 2 plus 3, and alpha plus beta was -5, then plus 9. If you can see here, we are getting 11 minus 15, which is going to translate to -4. So this translates to -4. So in the event now we have the sum and we have the product, we can be able, because our product is this and our sum was obtained here, we can be able to write the new equation whose roots are this. And that equation can be written as x squared minus the sum of the roots. The sum is 1, so we are going to say minus 1x. Because this is positive, now we're going to say minus 1x, and then minus 4, because we're going to add the product of the two roots, and our product is this one. So the final answer becomes what? X squared minus x minus 4 is equals to 0. We are almost done. Now we have this one, E, and in E we are told that the roots are alpha over beta and beta over alpha. So we need to find the sum. What is the sum of these two roots that I provided here? The sum is alpha over beta plus beta over alpha. And this means that the LCM, what's the LCM in this case? The LCM is alpha beta. Then how many times does beta go to alpha beta? It goes there alpha times, or you can even cross multiply like that. And then this is going to be alpha squared plus beta squared. Now, things are getting interesting here because we need to know there's no way, we don't have alpha squared beta squared anywhere here. So things are getting messy. So meaning that there's something else we need to do. And let me show you, just pretty simple. Yeah, we are going to say alpha plus beta. If you have alpha plus beta, we are trying to see how can you be able to get something like this, and what can it be replaced with, so that you can be able to substitute these two guys here. And then if you square this guy, let us see what this guy will give us. This is not related to this. I want you to save this. I want you to save this the way it is, like that. Just save it, leave it there. So this one is just new stuff, so that we can be able to, this is just new stuff, so that this is just new stuff, so that this is just new stuff, so that we can be able to know what are we going to replace this guy with, so that we can be able to substitute this and this. Now, if you're having alpha plus beta squared, that will be what? That will be alpha plus beta times alpha plus beta, isn't it? Yes. So meaning that if you expand, alpha times alpha will be alpha squared, alpha times beta it will be plus alpha beta, beta times alpha it will be plus alpha beta, beta times beta it will be beta squared. So you can see here having alpha squared appearing somewhere, beta squared appearing somewhere, plus 2 alpha beta, plus 2 alpha beta. And this is alpha squared plus beta squared. So which means that I can equally say, if I take this on the other side of the equal sign, yeah, if I take this on the other side of the equal sign, I know what alpha beta is, and I know what alpha plus beta squaring it can give me. I know that. So I can be able to say this one is equals to what? Same as alpha plus beta squared minus 2 alpha beta. So if you are having alpha squared plus beta squared, you can be able to replace this with that, right? And we have obtained it from this rearrangement. I've just taken 2 alpha beta on the other side of the equal sign. So I remain with alpha squared plus beta squared is equals to alpha plus beta squared minus 2 alpha beta. Now, since we were just doing this so that we can know what this can be replaced with, let me just do away with this part. Yeah. So I can say that my sum here, my sum can be written as alpha squared plus beta squared can be replaced with this, and that will be alpha plus beta squared minus 2 alpha beta over alpha beta over this alpha beta. So alpha squared plus beta squared can be replaced with this thing. That's what I've replaced here. And then now we can continue with the equation with the roots, original roots that we were having at this point. So sum is alpha plus beta squared. That will be minus 5 squared minus 2 into 2, because 2 alpha beta, 2 times 2 divide by 2, and that becomes what? Let's see what that becomes. This becomes 25 minus 4. 25 gives us 21 over 2. So we have the sum is 21 over 2. Then now we need to find the product. What's the product of the two roots? Product will be obtained. How will we obtain the product? The product will be alpha over beta times beta over alpha. This is alpha over beta times beta over alpha, and you can see the answer is going to be 1. So we have obtained the sum of the roots, we have obtained the product of the roots, and then now we are going to write the equation using this relation that I gave at this point. So we are going to say, now the equation becomes x squared. That's the first thing, x squared, negative of the sum of the roots. Negative of the sum of the roots becomes what? Negative 21 over 2x. Then plus the product. And the product we got it here. It's 1, and we say that is what? As integer coefficient. If you are told you want to integer coefficient, it means that you cannot leave your answer as a fraction. What you're going to do, you're going to multiply all through by 2 here, and this now equation of ours becomes, by multiplying all through by 2, we are going to have 2x squared minus 21x plus 2 is equals to 0. So if you have found value from this video, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. See you in the next video.